Hello, this video is for Stat 310 Handout 7 Part B and includes a discussion of the one-way ANOVA model with a blocking variable. All right, let's go ahead and get started then. So the example that we're going to look at here is a continuation of Part A, where we were interested in comparing three different alcohol levels, no alcohol, 1 ounce, 2 ounce, on reaction time. Now we know that reaction time is influenced by the age of the subject, so we're going to want to adjust out that effect, and we do that with a blocking variable. So here's the data that we have here. You can see that we got 3 individuals in the young age group, 3 individuals in the middle age group, and 3 individuals in the old age group. Now each individual there, so one of those individuals in the young group is going to be randomly assigned the no alcohol level. The other is going to be randomly assigned the 1 ounce and the 2 ounce. We're going to do that same thing here for the middle age. These individuals are going to be randomly assigned to either the none, 1 ounce, and 2 ounce, and the same thing for the older individuals. The visualization that we want to make is this one here. So let's go ahead and show you how to do that. First thing I'm going to do is color or mark by the different age groups. So I'm going to do that under rows, color or mark by column, and I'm going to specify here that I want to mark by the age groups. Now here the red is going to be the young, the green is going to be the middle-aged, and the blue is going to be the older. So that assigns the colors to each of those rows. The other thing that I did here is I have the variables ordered. So there's a value order being specified here for the alcohol consumption, because I want none, 1 ounce, and 2 ounce. Those are ordered, so we want that in that way. To make the graph, I'm going to select Analyze, Fit Y by X, put reaction time here, alcohol consumption here. That's the factor that I want to investigate. We'll get the visualization or the graph here. Now to connect the dots, what I need to do is just select Matching Column here. So that'll connect the dots. I got to tell it what to match by, which again is age. And that's the visualization that we have here. So when we talk about comparing the none, the average from the none, to the average from the 1 ounce to the average from the 2 ounce, we want to take into consideration what's happening within each of the age groups. So if I just isolate those age groups, I'm going to do that by applying a local data filter on age. So let's look at this graph here just for the young people. So that's what that looks like there. So just the red line. Okay, so I'm just filtering out what we call filtering out the other groups. So let me just look at the young first. You can see that the effect for none drops down here. It looks like it's dropping down about 0.1 or so. Over here on the 2 ounce, the effect of 2 ounce of alcohol increased by about 0.15. Now that's for the young group. Let's look at the effect for the middle age group. Here you can see again that the non-alcohol drops that by about 0.1 again. The increase over here for the middle age group due to 2 ounces looks like it's about 0.08 or so. So a little bit less than what I saw for the young. Let's look at the old. The old is essentially the same. So when we talk about the effect of no alcohol, adjusting for the age groups, what we're doing here is looking at this drop, okay, and kind of averaging that across the age groups. So that effect of no alcohol looks like it's going to be about negative 0.1 or so. Okay, so as I'm going across those age groups. And then I'm going to do that same thing for the 1 ounce and the 2 ounce. Obviously for the 2 ounces, again, this looks like it goes up by about 0.08. This goes up by about 0.08. And then the young group was even more. That looks like it's about 0.12 or so. So we're going to average that 0.08, that 0.08, and that 0.12. So that's what we mean by what is the effect of alcohol adjusting for the different age groups. Okay, so let's talk about the statistical model that we're going to end up fitting. The model is going to have an alpha terms in it. Let me maybe highlight those. It's going to have these alpha terms in it, which is going to be the effect due to the alcohol. And then it has these B effects, which are just stand for the different blocks. And those are going to be for the age groups here. So the B is for the different effects due to the block, which we're not really interested in comparing those. We just want to adjust those effects out of the model. To fit the model inside of the JMP package, we are going to use the fit model. So I'll show you that quickly. So we're going to go analyze fit model here. We're going to put the response here in the Y box, and then alcohol consumption and age are going to go into the model effect box. We'll go ahead and hit run here. We're going to get all sorts of output. Okay. The left-hand side is what I want to worry about first, and I'm going to minimize lots of this output because we are not going to consider lots of this output. The output that we want to look at here is actually going to be underneath the effect tests. And then we'll talk more about the multiple comparisons here when we get to that. So the right-hand side here are the multiple comparison output that we will be using. All right, let's go ahead and just continue with what we got in the notes here. So the overall test, the one underneath analysis of variance here, is going to test whether or not there's some effect due to either the alcohol or the age. Now, this test here has in it, or it's comparing both the alcohol and the different age groups. Now, my interest just lies in comparing the alcohol levels. So this test here is not all that meaningful because it has those effects combined. Okay, so we typically do not consider this overall analysis of variance p-value when we're talking about a model that has blocking in it. All right, let's go down and talk about the effect test now. And again, this output is down in the lower right-hand corner, lower left-hand corner of the jump output here. Okay, so I'm talking about the two p-values underneath the effect tests. Now, the first one we're not even going to look at, and that is going to be age. We want to exclude that one. Okay, because what this would be testing is whether or not I have an effect due to age on reaction time. And we do. We believed that. We set up this particular study assuming that age had an effect on reaction time. That's why I did the blocking. So the age p-value here, the one that is associated with the blocking variable, is not considered. The other, this one here, is the p-value for alcohol consumption. So that's the one that we do want to look at here. What is being tested by this p-value? Well, does alcohol consumption have an effect on average reaction time? In symbols, that's going to test whether or not each of those effects is equal to 0 versus at least one is different from 0. This p-value here, 0.0112, is less than 0.05, so we do have enough evidence to support the research question. Or we do have enough evidence to say, I have some effect somewhere due to alcohol. Okay, so that's what our conclusion is here. We do have enough statistical evidence to say there's a significant effect due to alcohol consumption on the average reaction time. Now, just like in Handout 6, we're going to want to go figure out where those differences exist. All right, so that's where we do our multiple comparisons. I'm going to skip over the expanded estimate stuff. These are just the different effects. So this would be the effect, overall effect. So that's going to be the mu hat here. That's the intercept term. Alcohol consumption, none. Okay, we said, well, each one of those dropped by about 0.1 or so. So that's what this is representing here. We said that the alcohol consumption for 2 ounces was, what did I say? The average of 0.12, 0.08, and 0.08 or whatever it was. That's what this is representing here. And then we have the different effects due to blocking as well. Okay, let's go into the multiple comparisons now. And I'm going to be doing the multiple comparisons for the alcohol consumption. Okay, so when I'm over here looking at my jump output again, I do not want to consider the multiple comparisons for age. Just like, same reason, we did not want to look at the p-value for age. I believe I have differences due to age and reaction time. That's how this study was set up. So I'm going to ignore all of the multiple comparison stuff for age, just like I ignored this p-value for age. Here, under alcohol consumption, I can either do Tukey's HSD, or I have, in this particular case, a control, the no alcohol level, right? So I could do Dunnett's procedure as well. So either one of those would be a viable option for our multiple comparisons. I think in the notes there I did Tukey's HSD, so that's going to give me this output here. Again, I often will ask for the lettering report, ordered difference report, excuse me, and that's going to just list out those comparisons with each of the p-values listed out here. So again, I got that from the ordered difference report. We can see from where my cursor's at here that there is only one significant difference, and that is between the 2 ounce and the none. Okay, the 2 ounce and the none, I have significant differences. I do not have significant differences on the other comparisons that are being done. Let's go back and look here in the notes. That's what this is saying here. When I do the comparison between none and 2 ounce, I do have statistical differences, but I don't on the other two. Again, this is using that Tukey HSD comparison method. There's that p-value that I just mentioned there. That one is the one that's less than 0.05. The connected letters report. Okay, so again, when we're trying to understand what that report is telling me, is if they have the same letter. Okay, so if they have the same letter, they are not different from one another. So when I compare the 2 ounce to the 1 ounce, okay, so that's going to be the jump from 2 ounce down to 1 ounce. That's where the mean is for 1 ounce there. That is not significant. So that gap there is not statistically significant. The 2 ounce has an A and the no alcohol level has a B. So those do not have the same letter. So I do have differences between the 2 ounce, which is here, and the none, which is here. So that gap is significant. And likewise, when I compare the 1 ounce to the none, those both have B's, so that gap is not significant. So where I have statistical differences here is between the none group and the 2 ounce group. And the other two comparisons, they are not statistically different from one another. Here I have what we call a custom test, okay? And that is when we can ask specific questions, so additional questions. So in this particular case, I might want to know, is there just some effect due to alcohol? Okay, so what we are doing when we do custom tests is, in this particular case, we would be combining the 1 ounce and 2 ounce into kind of its own bucket. So is there some effect due to alcohol? That's not worrying about if they were in the 1 ounce or 2 ounce group. I'm just taking the people that I have here and combining them with the people that I have here. And then I'm going to compare that set of people against the people that didn't have any alcohol. So essentially what we're doing again is, the research question is, there's some effect due to alcohol. We don't worry about if it's a 1 ounce or 2 ounce. So what we're going to do is take the people in these two groups and just average that. And then compare that average back against the none. So that's going to be a custom test or a contrast. Now when we're doing a contrast, we do have to write out what that effect looks like, or what that comparison looks like in terms of the different effects. So the no alcohol is the alpha 0, and then the 1 ounce and the 2 ounce are represented by the alpha 1 and the alpha 2. Okay, so we need to go through some algebra here to figure out what that contrast looks like. Now this is done under the condition that the sum of the effects have to equal 0. So there's a little bit of math here involved to figuring out what that effect looks like, or what that contrast looks like. So in order to test whether or not there's a difference between no alcohol consumption and some alcohol consumption, in order to do that test, what we need to do is determine whether or not 1/2 of the alpha 0 is different from 0. Again, this is coming from this algebra that's done up above. Underneath my estimates here, okay, so this is on the left-hand side again, I can do a custom test, which is underneath the estimates menu here. And then I need to put those coefficients in there, set it equal to 0. And then in my output down here in the box, I get the p-value for that contrast. And then here's the conclusion, decision, etc. for that particular contrast. Okay, so that's kind of a little side thing that we often will do when a researcher has a particular, or maybe a sub-question, sub-research question, okay, where we end up combining different groups and making statistical comparisons between those. When we combine those groups, that's called a contrast. Okay, this last is just a little bit about what happens if you ignore the blocking variable, which I think I'm going to skip over that. There are some, we certainly do not want to ignore a blocking variable. It reduces your power of the test if you ignore that blocking variable. So if a blocking variable exists in a study, you definitely want to adjust it out. Okay, that does it then for handout number 7, part B. Thank you very much and have a good day.